How's everyone? Welcome back to the workshop. So in this video we're going to be taking quite an in-depth look at how I make a liner lock folding knife. In particular we're going to be making a Damascus liner lock folding knife. So this was a piece of Damascus, it was an offcut from a billet that I forged for something else. It's a low layer twist and quite a lazy twist as well, but I still think it's going to make quite a cool pattern for a folding knife blade. So I've already surface ground both sides. You'll see some overlaid footage of that, basically making sure that we've got nice, flat, and especially parallel sides. Keeping everything nice and straight and parallel is really important for folding knives, and you'll see why later. So, hope you enjoy the video. This is how I make a Damascus liner lock folding knife. Okay, so this is the piece of steel that we're working with. So as I mentioned, this is an offcut of a billet of steel, Damascus steel. It's a twist pattern, but it's a nice, slow, lazy twist. And it was about between 25 and 30 layers when we started. So we're going to clean this off as best we can on one side, get that side super flat, and then we're going to head over to the milling machine. What we're going to do at this point, now that we've got it nice and flat on the one side, we're going to dip it in some ferric, just have a quick little test etch and see what kind of pattern we're dealing with. And there is our pattern. Low layer, lazy twist. That's going to be really awesome for this little folding knife. Now what we're using the milling machine. I've set up the billet on the flat side. I've super glued it down to a nice flat bar of aluminium that I've got secured in the milling vise. And I've got it secured so that it's running nice and true and parallel to the table and to the head of the mill. So we've now super glued the flat side of the billet down to that, and we're using a 12mm carbide end mill, and we're just taking nice shallow cuts up and down the billet, and we're slowly bringing down the top of that billet so that it's nice and flat and parallel to the side that we've already flattened. So by the time this is all said and done, we're going to have two sides of this billet that are both parallel to each other and nice and flat. And the last thing we're going to do to true up this billet is we're just going to take it back to the belt sander on a soft 80 grit belt, a used 80 grit belt I should say. And I'm just going to gently sand the face that we've just milled. This is because I'm not a very good machinist, and my machine doesn't leave the cleanest of finishing passes. No matter how light or fast I go, I just don't have the speed in my machine to get a really nice finishing pass. So we're just going to smooth it off, make sure everything is nice and true and flat, and then we're going to dip it in ferric chloride one last time so we can check the pattern on the other side of the blade. Alright, so the very first thing we want to do with our steel is we want to lay out our blade. So I've got some blue dicom here, or layout fluid for those who are non-brand sensitive. And this is just going to allow us to scribe lines that are going to be really easy to follow. Now, the model of the folder that we're going to be making is what I call my fish eagle. So this is a stainless steel blank of my fish eagle blade. So we're going to be using this as the template for our folding knife. Let's just make sure it's nice and dry. And honestly, are you ever actually using layout fluid if you don't get it on your fingers? Right, so I want the pattern about there. Take a nice scriber. And we're going to scribe in our blank. There it is there. Now, one thing we also want to do is get the location of our holes. Now, this has got an open stop pin design. I've done designs in the past where we have what's called a closed stop pin, where you'll mill basically a slot for the stop pin to run in. This knife doesn't have that. It allows us to basically just make sure that we have this pocket. This is where the stop pin is seated when the knife is in the open position, and when the knife rotates, the back of the knife here rests on the stop pin, and the stop pin is visible at all times. It also makes it a little bit easier to clean the knife without if you ever get pocket gunk or anything down into it, it's not such a problem. But it does mean that we need to mark the position of those holes now. What we're going to do to mark those holes, put our blade back on the template, line it up with our scribe holes from before. Okay, and then all I'm doing is I'm just using the drill bit for the correct size, just to mark our center line, sorry, our center point there, same there, same there. I'm not, on this Damascus blade, I'm not going to be adding a thumb stud. This is a flipper design, so it doesn't need a thumb stud, so I'm not going to add it. That gives me 3 points there that I can now come in and center punch. One there, one there, last one there. So the pivot is a 5mm hole and the stop pin holes are 2mm. So you can go to the drill press and drill those out quickly. Right, so let's go ahead and drill first of all our 2mm holes for our stop pins. Sometimes you might hit a piece of carbide on the steel, seeing this is Damascus steel. Could just be a piece of hardened steel there for whatever reason. In that case, I have a little 2mm carbide drill bit. So in theory, this will go right through. You may ask the question, well, why didn't I just start with that drill bit? The reason being, they are about 5 times the price of a regular 2mm drill bit, and I cannot get them locally. I have to import these, which means if I don't have any, it's a 2-week waiting period to get one. So I look after them. I only use them when I absolutely have to. Right, what we're going to do now is we're going to drill the main pivot point, main pivot hole. Now that's a 5mm hole, but I'm going to start by drilling a 4. I'm going to start undersize and then bring it to oversize. Let's go there. That is our 4mm hole drilled. Now we're going to up it to 5. The reason I drill 4 and then 5 is essentially we don't want to overwork the 4mm so that it's there's a chance that it'll overlies the hole if we're not careful. It doesn't matter if the 4 mil is a little bit overlised because we're drilling with a 5 after it. But if the 5 was overlised, well, it's not ideal. There we go, that's nicely lined up. Right. Oh dear. Now there is a blind drill bit. Is that a blind drill bit? Yeah, corners. Right. I'm going to sharpen this. Be back in a second.
A few moments later.
Okay, let's try this again. We've got a brand new drill bit. I've slowed down the drill press. Let's see if we can get this hole done. Okay. Plan C time.
One eternity later.
Alright everyone, new plan. We are firmly in plan C territory here. So I have got the blade secured in the milling machine. I used parallels underneath it to set it up and then remove the parallels from underneath it. So we're nice and square, and then I've got a 5mm carbide end mill located plumb on the center of that hole. Should be plumb on the center of that hole. Now this is a manual milling machine. There's no DRO. Well, I've got a vertical DRO. That's it. And all it does is tell me, just gives me a measurement. I don't have any power feeds, anything. It's a pure manual milling machine. So yeah, let's see how this goes. Well, we're coming up nice and square, that's good. Just a little bit at a time. There we go, all the way through. Okay, we now have a nice 5mm hole for our pivot screw. Now we can go to the bandsaw and we can cut out the profile of our knife as close to the line as we can, but remember we don't want to go over the line. Alright, and what we're about to do here is we're going to mill the bearing pockets into the blade. So we're using caged ceramic bearings in this knife, and they are 1.6 millimeters tall. That's the diameter of the ceramic balls inside them. Now, with some math, we can work out exactly how deep we need to cut into each side of the blade for our bearing pockets. And the magic number is 1.35 millimeters. That's how far we want to cut down in. So I've got this little jig that I've made out of brass. It holds the blade nice and square, and it allows me to locate the blade so that the pivot hole is directly under the end mill, and it's centered. So once it goes into the jig, we tighten it down, and then we can plunge cut using a 12 millimeter end mill, 1.35. Now, this is where the one bit of digital readout I have on this milling machine is. It's an aftermarket thing, an Amazon special that I bought and fixed it to the mill, and it works really, really well. And it gives me a digital readout and allows me to make sure that I go down exactly 1.35 mils. We cut it one side, then we'll flip it over, do the other side, and that's our bearing pockets, all done. Rightio, so that's pretty much everything we need to do to the blade now before heat treat. It is ready to go through thermocycling, heat treat, at which point then we'll do the final grinding and everything to this blade. Those pockets that we cut for the relieving of the bearings, you see that the bearing does fit in there really nicely. That's why I've oversized it to a 12 instead of using the 10 like I used to. It just gives us more space. And there's no harm in it. So, what we're going to do with this blade right now, in preparation for thermocycling and heat treatment, is we are going to coat it with an anti-scaling compound called chondrosol. So this is effectively, I think, well, it's an anti-scaling compound is what it is. It does what it says on the tin, really. It stops the blade from producing scale during heat treatment. So we're just going to make that a bit long. Oh boy. I'm getting it everywhere. There we go. Alright. That's going to drip and just catch any extra chondrosol that we don't need on the blade. That'll dry. And then that's now ready for thermocycling and heat treat. I'll probably shoot that as well and explain that a little bit closer to the time. So here are the blades out of the first round of thermocycling. I did a couple of others as well at the same time. I like to heat up my kiln and do a lot of things all together at the same time to save on power. So first round of thermocycling happens at 900 degrees Celsius. Then we let them air cool. Following this, we'll heat them up to 840 degrees Celsius, then let them cool. Then last round will be 770 degrees Celsius, let them cool. And then we'll heat to 830 and quench in a engineered quenching oil. Alright, now that we have quenched and tempered, I tempered the blade at 205 degrees for 2 hours and 2 cycles. Now what we're going to do is we're just going to give it one final cleanup. We're going to run it through the grits till we get to 400 grit, nice and clean. Then we're going to etch it, have a look at the pattern we have on the blade itself, and then that'll be that. Right, so we have successfully shaped, machined, and heat treated, and then cleaned up our folding knife blade. So, lovely low layer twist. You can see the pattern. I think it's going to look really, really cool on this knife. But that's pretty much the blade done up until this point. From here on out, we're going to be transitioning over to the handle now. And once we've got the blade fitted up to the handle and the handle figured out, then we'll grind the bevels, hand sand, and etch this thing properly. So that's going to be the end of this particular video. This is part 1 of making this folding knife. So in part 2, we're going to start off by looking at putting together the handle, the mechanism, and the rest of the internal workings of this folding knife. If you watched this episode so far, thanks very much guys, greatly appreciated. See you next time.